So we did long division, okay, and you just thoroughly enjoyed that, okay? And so now we're going to do something that's called synthetic division. Now, long division can be used for in any circumstance when you're dividing polynomials. Synthetic division can only be used when your divisor is in the form of x minus a. So that would be like x plus 3, x minus 7, something like that. Okay? If the divisor has any squares, or if there's a coefficient of x, like it said 2x plus 3, you can't use synthetic division for that. I mean, let me rephrase that. You could use it for it, but the only thing is that there's some manipulation that has to take place at the end. So you're better off to not. So for synthetic division, anytime we have our divisor in that form of x minus a, it's going to be a whole lot easier for you to divide. Okay. Now this just tells you the steps for getting there, and I'm going to show you how to do it. Now, okay, all of you did number 16 yesterday, right? Okay, and so we're going to use number 16 as our example. So if you have your homework paper there where you can see it, so take a look at number 16 on your homework paper while we're doing it with synthetic division. And I'm just curious, how many lines did you use for number 6 for this problem? A lot? Okay. How many? 10, 11. Okay, that's a lot of lines, right? Okay. 10. Okay. We're going to do it with 3 lines and an answer. Okay? All right. So this is how synthetic division works. Okay. First of all, what you're going to do is we need to determine the a 0. Okay? So for instance, there is, when we set up synthetic division, it's always going to be set up like they have here in this top part right here. Okay? It's always going to be set up there. So what we need to do is we need to figure out what the value of a is. Okay? The value of a is the most important part of our starting. So if it's a linear factor and it's in the form of x minus a, we need to figure out what the value of a is first of all. So in this case, what would be our value for a? 4. Okay? So I think of it a couple different ways. I think of it as like the 0. If I wanted to find the 0 for this factor here, okay, what would that 0 be? All right? Okay, it would be 4. Right? Or the value of a is 4. So we're going to take that value of a and we're going to put it right here in this little half a box. That's our value of a. And then on the same line on our paper, we're going to put the coefficients of our dividend. Okay? So what's the coefficient of x squared, x to the 4th? Okay, so I put a 1. Of x cubed, negative 3. Okay, so make sure you put a little bit of space there. Don't put them right next to each other. All right. How about of x squared? No, what's the coefficient of x squared? 0. Did you guys remember to put 0x squared when you did the dividing yesterday? Okay, so in synthetic division, we have to put a 0 in there for our coefficient of x squared. Right? You can't forget that. If you forget it, you're going to be in trouble. Okay, coefficient of x, negative 7, and then the constant is negative 14. Okay, so now skip a line and draw a long line, kind of like fraction bar. Okay, now in all of our division that we did, okay, the long division that we did, when we had x to the 4th here, 1x to the 4th, we were always going to end up with 1x cubed would be our first term for our answer. Okay, so in this case, what we're going to do for synthetic division is we're going to take this number and we're going to bring it down, and it's going to go down here underneath that line. All right? Because when I divide, okay, so think about this. When I take x to the 4th and I divide by x, what do I get? X cubed, right? So I'm going to have 1x cubed when I'm done here. Okay? Now, this is how synthetic division works. And we're going to end up, you're going to have the same numbers here when we're done as you have when you did your long division, except we're not going to have all the variables. Okay? So, here's where we go. We take, after we figured out what our coefficient was, right, when we did our long division, the next thing we did was multiply, right? Okay? So, we're going to multiply. 4, we're going to take 4 times 1. What's 4 times 1? 4. And we're going to put that number here. Right? And then, we're going to combine these two numbers. What's negative 3 plus 4? 1. Okay? So there's a 1 goes there. Okay? Right? And then we're going to continue that pattern until we're done. So now I'm going to take 4, this 4 in my box here, and I'm going to multiply it by this 1. Okay? And I get 4. And 0 plus 4 is 4. Okay? And then we'll do it again. 4 times 4, so we're going to take this 4, multiply it by that 4, and it goes there. So we get 16. Okay? Negative 7 plus 16 is 9. All right, then we'll do it again. Take 4, multiply it by 9, and we get 36. And negative 14 plus 36 is 22. Okay? Now, look, turn back to your number 16 that you did in long division. Okay? And you'll notice, okay, these are all the coefficients you have in the above your dividing symbol, right? 1, 1, 4. So you have x cubed, x squared, 4x, and 9, and then a remainder of 22, didn't you? Okay? All right. And then in the process of your long division, you also had the numbers 4, 4, 16, and 36, didn't you? Okay? So all those numbers showed up in your long division, but hey, those represent our answer. So this is how it works then when I'm writing my answer. This is my remainder. Okay? Here's the constant. Here's my x term, my x squared, my x cubed. So we have x cubed plus x squared plus 4x plus 9 with a remainder of 22 over x minus 4. So we use 3 lines for what some of you use 10 or 11 lines to do. Okay. But we have all the same numbers that you used in that problem. Okay. Kind of neat, huh? Okay. And all it takes is being able to multiply and add. What's that? Okay. Now, here's the other part then. Okay. Is that I know that this represents x cubed. The first one represents x cubed because I'm taking x to the 4th and dividing by x. So the first term I've got to have is x cubed. Because remember, if we checked our answer, we would take this and multiply it by x minus 4, right? So I'd have x cubed times x would give me x to the 4th. And then have x squared times x would give me x cubed, and so on. Okay? So I'm reducing by taking x to the 4th and dividing by x, I'm always going to reduce the power. My first term in my answer is always going to be 1 degree less than my dividend. Okay. All right, let's do another one. And so I have a little caution here, so let's read my caution here first before we go on. It says, be careful to use the correct a value when doing synthetic division. Reminder that with divisors x minus a, you're using a positive a. If the divisor is x plus a, then it's a negative a. All right. Okay, so here's our other example. And remember, it's always got to be in standard form for the dividend. So we put our little L, half a box, whatever you want to call it, and A goes in there. Okay? So what's A going to be in this case? -2. And this is the biggest, and I'm going to tell you this right now, okay, so you're aware of this. Okay? When you do these problems on a quiz or a test for me, they're worth 4 points. If you use +2 here instead of -2, I'm going to immediately take 2 points off. Okay, that's how important that is. Okay. So now we list our coefficients. 3. Coefficient of x cubed is? -1. Coefficient of x squared is? 0. Don't forget that. Coefficient of x is, and our constant is -1. So we leave a little space and draw a line. Okay. Always bring down the first one. That one comes down. Okay. Then we multiply. -2 times 3 is? -6. Now, the only difference from the long division is we're not subtracting, we're just combining them, okay? So -1 plus -6 is -7. Okay. Then we multiply again. -2 times -7 is 14. So we combine them. 0 plus 14 is 14. Okay. Then we multiply. Okay. Combine them. Okay. 5 minus 28 is -23. -2 times -23 is 46. And so we have a remainder of 45. Now that remainder number is very important. Like I said yesterday when we were talking about it, that's very important because it's going to tell us a lot of things. Okay. Yep, the last one's always a remainder. What was the last one in your long division? Okay, but the remainder was, that last number in your long division was a remainder also. Okay. So my powers are always reduced by 1. So if I started with x to the 4th, we have 3x cubed minus 7x squared plus 14x minus 23 and plus 45 over x plus 2. And that is our answer. What do you think? Would you rather do that or long division? Okay. With the synthetic division, we have something that we call synthetic substitution. And where we're going to basically be using synthetic division, but all we care about is the remainder. Because what we're going to be doing is, they have this thing called the remainder theorem, and I'm going to show you there's 2 ways that this remainder theorem works. And it's really interesting because we're going to take a look at our calculator and see what happens. Because all we're going to be doing, that all synthetic division does when we're looking at the remainder, is basically it says, okay, put that number in for x, find the answer. Okay? All right. You guys have done lots of those, but it used to say, evaluate this when x equals 5, or evaluate this when y equals 3. Okay? It's going to produce the same thing. But we're going to be doing it with using synthetic division, or we're going to call it synthetic substitution for this. And it's something where you can actually do it in your head, where normally you would have used your calculator for. Okay? So it says evaluate this polynomial. Oops. Evaluate the polynomial for the given value. Well, it used to be you would do this then. And you might still do this. 2 times 2 cubed plus 5 times 2 squared minus 2 plus 7. When we do synthetic division, that's all we're doing to find the remainder. Okay. So if they ask me to use, they're specifically saying, okay, I want you to use synthetic substitution to do this. So it tells me x equals 2. So that's my value for A. Okay? So in this case, A is going to be 2. Because it says x equals this number. And when it's dividing, it gives me a factor, okay, a divisor. And so then we're using the opposite there. But in this case, when it says x equals 2, then you got to use 2. Set up my synthetic with my coefficients. 2x cubed, 5x squared, negative 1x, and 7. Bring your 2 down, and then we just go through the process. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 1 plus 18 is 17. 2 times 17 is 34. So we get 41. So this is my answer right there. So if you put 2 in for x, you will get 41. Yep. What's that? Yes. Didn't you see that me draw it? Oh, I'm amazing, aren't I? So, okay, here's the other thing. Okay, take out your calculator. This one I was having issues yesterday too. There we go. Okay, so put 2x cubed plus 5x squared minus x plus 7. Put that in your y equals. Now I'm going to show you 2 things. Okay, one is, where can I find when x equals 2? Okay, in the table. All right, so I go to the table, second graph, when x equals 2, y equals 41. Okay, hey, there's that same number. Okay, or I could graph it. Make sure I'm in there. And so here's the graph of that. Okay, at least a little bit of it anyway. Okay. But if I hit trace, okay, all right, I want you to do this. Hit trace, and then just type in 2, because it will say x equals 2. We get 41. Okay. So there is 4 different ways, basically, to find that answer of 41. Yes, Elijah. Okay. Oh, you've got, okay, hold on. You got a plot on here. Go up to that where it says plot on, go up, and then hit enter. and I'll turn it off. Okay, now go ahead and graph it. It'll work now. There you go. Okay. Chase, you got a question too?
Yeah, how does this say?
Okay.
Like the x is the variable in the bottom.
Okay. There we go. Yeah, we had something turned off, so, okay. I will give you a contract. Who are you living with? Marie? Okay. Just a second. Yes, Stephanie?
I just keep saying y equals 7.
Really? Now you got x equals 0.
Yeah.
Okay. Put in 2. Just hit type 2 and enter. Oops. Oh, okay, hit trace. Okay, now put 2 and enter. There you go. Okay. Okay. So take this home and have her sign it, okay, and then bring it back to me, and then I'll give you a calculator you can take home with you, okay? All right, Spencer? Well, why don't you put in 2 instead of 1? Wow, 13,536. Okay. All right. Now, here's one of the things you need to always check. Okay. Everybody go to your y equals for a second. All right. I'm going to have Spencer go to his y equals. Okay. Go to your y equals, and if any of these are highlighted, okay, all right, you need to turn them off. And it's really easy to turn them off. You just go up to whichever one it is. If you hit enter, it turns it on. If you enter again, it'll turn it off. Okay, so we had 2 people that had graphs, had plots on. And if you have a plot on, then sometimes it'll mess up because it's looking at that data, not the information from the graph. Okay, you good now, Spencer? Mm-hmm. Okay. So that gives you another way to check them. All right, so let's see. All right, so you guys find this one. Do it with synthetic. And you have to use you're working with a fraction. I know you hate fractions. That's okay. All right. A lot of times fractions are your friend. Isn't that cool? I use decimals very seldom in this class. All right. You need to be efficient with fractions. So. If you do it right, the numbers turn out good here. And don't forget your x squared. Nope, it's negative 1/3 because it says x equals negative 1/3. It's telling you what it is. Right. So really, this fraction wasn't so bad, was it? Because it used all even numbers, all correct factors of 3, so that it was easy to use the fractions. So, okay. All right, last thing here then, we have a geometry application problem. Oh, and I did want to say one other thing, is that when you write your answer here, okay, you should write your answer for both of these. When I say my final answer, I should put P of 2 equals 41. Okay, and P of negative 1/3 equals 7. All right. Yes, Brooke. You got 6? All right. See it right there? That's a negative sign. So it's multiplying. And if you put a minus sign, then you should, oops. Now if I put in negative 1/3, let's see if it cooperates. I did it too soon. If you try now, it should work then. Okay. So this says, write an expression that represents the area of the top face of a rectangular prism when the height is x plus 2 and the volume is x cubed minus x squared minus 6x. So basically what we're going to do is we're going to do some division, okay? But factoring is a type of division also. So let's take a look at this. We've got our volume is equal to x cubed minus x squared minus 6x. Well, when we're talking about volume, and we're talking about a rectangular prism, how do I find the volume of a rectangular prism? Length times width times height. Because basically all a rectangular prism is your book, right? Okay, it's just a box. Okay, length times width times height. Okay, so this is the same as LWH. Okay. So I have three different factors here, don't I? The length is a factor, the width is a factor, and the height is a factor. All right. So, if we look at this, all right, they have something in common, don't they? They have an x in common, so I can take that out. So it says, write an expression that represents the area of the top face of a rectangular prism when the height is x plus 2. Okay. X squared minus x minus 6. Does that look familiar? Okay. What goes here? Really easy. This is really, really easy, okay? Here's why, okay? The only, because if I multiply these two things together, I better get what? X squared. So the only thing this can be is an x, right? Okay? And if I multiply these two numbers together, there's only one thing I can get. What is it? Negative 6. So 2 times what is negative 6? Negative 3. Okay? So if this represents my height, then the area of the top is x squared minus 3x. Right? This times this. Now, you could have done division to find that also. All right? We could have done synthetic division. We could have done long division. Okay? Just in this case, might have been easier to do it this way. Right? But I could have done synthetic division. I could have put negative 2 in my little square there, because that's what A is, right? A would be negative 2. And then use 1, negative 1, negative 6, and 0 with synthetic division. And we would have found that we get 1, negative 2 here, which is negative 3, and positive 6, which is 0. So we have, and then 0 and 0. So here's my remainder 0, my x term, or my constant, my x, and my x squared. Okay, so I could have used synthetic division to find that answer also. Any questions about that? Pretty simple stuff.